Okay, so now I'm going to press play and we're going to see the solution flow through the whole system. So after a few seconds, it started, and we can see there are drops coming through. So while that is running, we can just continually circulate. This is just the background solution. So now we can tell this instrument here to do a background, and we're going to do reaction monitoring now. So to do reaction monitoring, you're going to choose this icon right here. Let's see if I can make this a bit bigger. Okay, so I'm going to choose that, test reaction monitoring. Select. Again, you can give it a name, so we'll call this one this. We can change you can do a lot of functions here. So this is if you want to do a Gram-Schmidt calculation, or you can load an integration method. So if you're going to do the same reaction over and over again, you can create an integration method and then load that, so that can be a different video. Or you can also upload a spectrum of your starting material and a spectrum of your products, along with intermediates and your solvents, and the instrument can do a lot of work for you. But on today's video, we're just going to do it all manually, basically. So we're going to go to advanced again. Sure, that looks fine. Let's do absorbance, see the difference. The display will still be like that. And let's do a background. So the time interval, you can also change the time interval between scans. So if you have a 8 sample scan time is 8, then your time between intervals has to be greater than 8, because the start of the one, then 8 seconds later it finishes. But then your time interval also starts counting at the beginning of the first scan. So if you make this 4, then the instrument if it starts scanning, then but it scans for 8 seconds, then at 4 seconds it's going to think, oh, I have to start the next one, but I'm not done the previous one, and it's going to give you an error. So this has to be greater than 8. So let's make it 12, which means it's going to start the next one 4 seconds after the first one finished, hopefully. So we're going to do a background single channel. So now we're running the background as background solution is being circulated through the flow cell. Okay, so that is done. So now let's rinse out all of the solution in the flow cell by letting it run dry. So this is the inlet valve, this is the tubing that goes into the flow cell, so I'm taking that out of solution. And solution is still coming out of the outlet from the flow cell because we're emptying it. And soon you're just going to see air bubbles are going to come out. It's already sputtering, so most of the air is left. When that's ready, we're going to switch to our solution here, which has some methanol in it. Methanol and DCM, so hopefully we'll see a nice broad alcohol stretch. Okay, so that looks about done. Okay, and I'm gonna hit play again. Now we can go back to this instrument and start the reaction monitoring. So when you hit start reaction monitoring, this new screen appears, which has multiple windows. Right now it is doing the first scan, and now that the first scan has been completed, it is showing in this corner the spectrum that has been collected. So this is now 2 spectra has been collected, so 2 spectra overlapping are shown here. And this window is where any traces that you create will be displayed. So we're going to create an integration trace soon. Here is a 3D plot of your absorbance, your wavelength, and time. Here are all the data points that are being collected, and each of these data points has a timestamp and a time since beginning, since you hit start, as well as an index, and then you can click on them to show them at various places. This area right here has also some information for you. These are rotation angles and tilt angles for your 3D plot. It has markers, so this blue marker here and this red marker, we can deactivate them, we can activate them. You can also change what these markers indicate. So let's select a few of these. So now they're all going to be displayed here. Let's make this window a bit bigger so we can see better. And let's zoom in. So we're expecting an alcohol. So OH has a broad region here. Let's see what's going on. What's neat, so what I really like about the 3D plot is we can click and drag it. So it is showing the region that I zoomed in on this plot. It is showing me zoomed in here. And we can see that this peak grew in over time, this peak grew in over time, as this is the time axis. But now we're going to integrate those. So we're going to select integration. You can select integration modes too. We're going to go with integration mode A. And so you left click and you drag across an area that you want to integrate. So we're going to integrate that. Actually, I'm not sure, so I'll do the whole thing. Right click and say integration, integrate. And now, over here, it is telling you that the light blue is being used and its evaluation is integration A, mode A, and it is from 2764 to 3584 wave numbers. That's where the integration happened. And here is what that integration, the integration number is on the y-axis and the time is on the x-axis. So this is telling me that at time 0 there was none of this, and at time about 80 complete amount, and then it's leveled out, which makes total sense because we started with just dichloromethane and then we had air. While there was air in the cell, we started collecting, and then we added the flask or the test tube with the methanol in it, and it started, the pump moved that solution into the flow cell, which was probably this time period right here. So you can just let it keep going. When you feel like it's done, you go to data, you can do data pretreatment. We want to do to endpoint, and you click stop measurement. When you hit stop measurement, it's still going to keep going until the end of that scan. So let's hit stop measurement. So it's still going. It's going to wait till it's done, and then it's going to stop. Oh, it's done. So now, if you still want to see it, is it this one maybe? Ah, there we go. There's the whole thing. So let's say you have made this integration trace, which is the important reaction data that you're probably gonna need. Then what you can do is you can export that. So you're gonna go to export trace as plain ASCII. That means it's gonna give you an X and a Y value. So I exported that, which means now I want to go find that so I can open it in Excel. So to find that, you go to where it would have been saved, where you set it up to save, which on this computer is going to be under Opus, and then where's it? Mes for measurement, and here it should be. So integration. So here it says video stem reaction mon trace 01 integration, DPT file, so it's a data point file. And we can open that with Excel. Okay, right now it's just being opened in Notepad, which will show you the X's and the Y's. You can import this into Excel, and then you can create a graph there, etc., do your thing. I'm not going to show you how to do that, but this is what it looks like. So at 0, it's this value, 12, it's that value. Okay, you can do the same thing with the actual integration traces. So for example, if we want to see what happened to it. you can do baseline correction on that and smooth it out. But let's say we want to export this one trace, so there's one spectrum, as X's and Y's. You can select it with the left arrow, right-clicked it, and you can say export selected spectra as plain ASCII. And again, it'll create a data point file with an X and a Y, and you can use that X and Y data, of course, every which way you want. Do anything with it. You can also use extract selected spectra. So I extract it, and it extracts it as a data file that only this program uses, Opus. So an Opus file, which shows you that one spectrum by itself, as if you had done a single measurement. And then you can change this, you can do data manipulation on this, you can do evaluations on this, so you can integrate different areas here, you can pick on here, etc. And then you can also export from here to make it an X and a Y file, like a plain ASCII file, to then use in other programs.